Hey everyone, and welcome to episode 5 of my Help with Maths homework series. Today we're covering differentiation and circular geometry, so make sure to stick to the end as I have a special guest today to help me with your maths homework. Okay, so first question. Alright, so we want to find the derivative of y equals 10x degrees on 2, and just to save time I'm going to write the other one on this side. Y equals ln brackets square root sine x. Okay, so let's put it on the side here. I picked these questions for a couple of reasons because there's a few tricks here we can use to help us. Well, first of all, when we're differentiating trig functions, we can only differentiate in radians. This is in degrees, so currently we cannot differentiate. So the way I like to remember these conversions is pi radians equals 180 degrees. So all I need to do is work out, well, what's x degrees? All right, so if I divide by 180, I get that pi on 180 rads equals 1 degrees. So then if I times both sides by x, I get pi on 180 x rad equals x degrees. So now I sub that into there, and we get y equals 10 brackets. Now it'll be pi on 360 x radians, right? Because we're dividing by 2. And now I can differentiate that simple, right? Because the derivative of 10 is just sec squared, right? That's a simple derivative. And what we have to do also, be careful, is make sure we put the derivative of the inside at the front. So the derivative of the inside is just pi on 360 because the derivative of x is 1. So then that's just pi on 360 at the front. So that question's really simple, except the trick was we had to convert degrees to radians. So that's why I picked that. I wanted to show you. We can only differentiate when it's in radians, so we need to convert it. Right, let's look at this next example. Alright, y equals ln brackets square root x. Now the rule for differentiating logs is this: y equals f dash x on f of x. Currently, if we try to do that, we have to differentiate square root sine x, which is not fun. But here's the trick. When we're differentiating with logs, always look out to use log laws, because square root sine x can be written as sine x to the power of a half, all of that. And when we have something to a power in logs, we can bring that power to the front. So now that's just half ln sine x. And look how much better that is, because all I have to do now is differentiate sine x, which is very easy. Because now the derivative y dash is just a half times cos x over sine x. And if you want to simplify that, we can, because cos x over sine x is actually cot. And it's helpful to write that because if I wanted to integrate cot, I go backwards. Right? So I just want to show you these slight tricks with derivatives using log laws and converting degrees to radians for trig functions. Okay, so make sure to welcome my next guest to solve the next question. Hey everyone, it's me, Goku. Maybe some of you probably know me from Saving the Earth, but what you didn't know is that I love maths, and I hired Nathan to help me with maths. So today I'd like to show you what I've learnt with Nathan, and we've got a nice question here on circular geometry. This is my favourite. This is why I came today. So the question which you'll see here, alright, let's draw the circle. Alright, in the figure, okay, we've got the line AB, the centre. Alright. Oops, I drew it the wrong way around, sorry. Okay. And we need to find the radius of this circle. Right. So we're given that they're both 15. That's M. And I want to find the radius of this circle, so I'll connect that there. That's the radius. And that length is 9. Yeah. Okay guys, so I love Circle Geo, that's why I'm doing this one. So with Circle Geo, we've got a center and we've got a chord. And the trick here to help us find the radius is that they're perpendicular, because this is the midpoint. So we've drawn the chord, the center to the chord, to the midpoint of that chord, so that means this is the perpendicular. And because that's perpendicular, that's 90 degrees. So what we have is we have 90-degree triangles, and we're trying to find this radius. So you can see in this triangle, what can we find to help us find R? And that would be this angle here, theta. Because then, look here, if this is theta, this angle here is 2 theta, right? Because this is the angle at the circumference is half the angle at the center on the same arc. See how both these angles start from this arc? So if I find theta, I'll be able to get that angle, and then we can use basic trigonometry. So in this triangle, to find theta, we'll use tan theta. So tan theta is 9 on 15. Now, I do need a calculator to do this. I'm not that good with inversing tan. So we get theta equals 30 degrees and 58 minutes, which means angle AOM is twice that. So that is 61 degrees and 56 minutes. So then to find R now, we can use sine. So sine 61, 56 degrees equals 15 on R. Right. Opposite over hypotenuse. So then R, if we swap positions, is 15 on sine 61, 56 degrees equals, we just use the calculator again because fortunately I can't do that without one. And we're going to get 16.999, which means it's going to be 17.0 centimeters. Okay guys, that's Circle Geo and with a bit of basic trig. I love this stuff, and make sure to subscribe to Nathan because thanks to him, I know how to do Circle Geo. Alright guys, so I've got to go now, save the earth. Thank you Goku for those kind words and for helping us out today with Circle Geo. If you guys want to see more of Goku, make sure to comment below it. And otherwise, I hope you guys enjoyed today's homework, learn a few things. Make sure again to subscribe, put those bell notifications on so that you get updated when the new videos are out, and I'll see you guys on Monday. Whoa, you made it to the end. Thank you for watching, and I hope you learned something awesome today. I post 6 videos a week, Monday to Saturday, so make sure to subscribe here, turn those bell notifications on, and watch other awesome videos on my channel right here, okay, right here. Oh yeah, don't forget to like, comment, and share. Spread the maths love. Can we go to the gym now?